right, guys. Let's see. Sally's excused today. Kayla, Mason, here's Zachary Crampton, Riley, Jaylianne here, Val here, Katie, Dakota excused, Dalton, Dawson is excused today, Olivia, Nate here, Mary here, Mandy here, Sharon here, Austin's here. All right. Today and Wednesday, we're going to talk about pricing bonds that may default. But before doing that, we will do a quick reminder on expected value and risk of uncertain cash flows. Until now, we kind of looked at those things in the past, but we're going to do a forward-looking assessment of expected values and risks. Let's remind ourselves the concept of a random variable. And uncertain quantity. Where we can attach probabilities to distinct outcomes. I mean, the name itself is kind of a misnomer. There is nothing random about a random variable, and it's not even a variable. It's basically a function. A discrete random variable takes on a countable number of possible values. Can be finite, but it needs to be countable. A continuous random variable can take on any value, which are uncountably many, in a given interval. In mathematics, we make a distinction between countable infinities and uncountable infinities. For example, the set of all natural numbers, 0, 1, 2, 3, until infinity. Technically, you can count them, right? What's not as well known, the set of all rational numbers, for example, all ratios, they are also countable. But the set of all real numbers, they are not countable. Countable means you can have a one-to-one and onto mapping from that set into the set of natural numbers. For Discrete random variables. Bless you. We define expected value of a random variable designated with typically a capital letter. Say X, by calculating the weighted sum of all possible values, weighted average, I'm sorry, where weights are probabilities associated with those possible values. Let's immediately do an example. For example, you are an insurance company and you have exactly one customer. You will pay an expected amount of $10,000 to this client if the client has an accident, which happens with a probability of, let's say, 10%. Hence, the random variable of interest is the total amount of damages paid how many possible values are there for those damages? 2. What are those? 0 and 10,000. Hence, this is a discrete random variable. Hence, probability of possible values are 0 and 10,000. Probability of 0 is 90%, and probability of 10,000 is 10%. Values of X. Hence, expected value of X. And we will make these calculations in Excel, but just to illustrate here, probability of 0 times 0, because that's the possible value, plus probability of 10,000 times 10,000. Oops. Got it the wrong way. So expected loss to the insurance company is $1,000. Okay. We can extend this. Suppose now you have 2 customers, but probability of them having an accident is independent of each other. which means, let's say Spook and Kayla are my customers. Knowing that Kayla had an accident doesn't change my opinion about whether or not Spook is going to have an accident.